Hi guys. Okay, so today we're going to look at the derivatives of inverse functions. So the first thing is I'm going to give you the function f of x is x squared. So its inverse, f inverse of x equals g of x, is the square root of x. So we have a function f of x is x squared, and its inverse, g of x, is the square root of x. So I want to find f prime of x and g prime of x. So f prime of x, the derivative of x squared, is 2x. Now remember, if g of x is the square root of x, that's x to the 1/2, which means that g prime of x is 1/2 x. Subtract 1, you get negative 1/2. So g prime of x is 1 over 2 radical x. So this is g prime of x, this is f prime of x. Now, we're going to use our calculator in a moment to complete this table for these x values. And remember, 0.5 is really 1/2 and 1.5 is really 3/2. You'll see why I wrote it like that in a little while. Now, we're going to take these x values. We want to evaluate f of x, f prime of x, and g prime of f of x. So you can easily use your calculator for this. I mean, you could plug in all those numbers into all three functions, or you could just put things in your graph page. For instance, we can put the function f of x into f1 of x. We can put the function g of x into f2 of x. We can put the derivative of f into f3 of x. We can put the derivative of g into f4 of x. That means our table is going to come from f1 of x, it's going to come from f3 of x, and then this last column will make f5 of x equal to the derivative of g, which we have in f4, of f of x, which we have in f1 of x. Okay, you ready? Let's go to our calculator. Okay, so here we are. We're going to put in a graph page. In f1, we said we're going to put x squared. In f2 of x, we're going to put g of x, which is the square root of x. In f3 of x, we're going to put f prime of x, which was 2 of x. In f4 of x, we're going to put g prime, which is fraction template, 1 over 2 radical x. Make sure you use that fraction template. And f5, we were going to do f4 of f1 of x and hit enter. Now that is a really messy screen. You know I hate that. But I really want to look at the table because that's what we want to do. So I'm going to Control T to get to my table. So here we are. Let's give ourselves a little more room here. So the first column we need to copy, and we'll have to go back in and put these by half so we can put in. So we can do Menu, Table, Edit Table Settings. Table start should be at 0.5, and we want the step to be 0.5. Okay, there we go. So we have f of x is 0.25, which is 1. At 1, it's 1. At 3/2, it's 2.25, which is the same as 9/4. At 2, we're 4. And we're going to go, let's see, 3 is 9, 4 is 16. Now we're going to go up. We need f3. So it's just out of my window here. Here's f3, and we're not worrying about f4. We want f3 and f5. So we have, I went too high. There. We've got 1 and 1. We've got 2 and 0.5, which is 1/2. 3, 0.3333, that's 1/3, right? 2 is 4 and 0.25. 3 is 6 and 0.166666. That, by the way, is 1/6. And 4 is 8 and 0.125, which is the fraction 1/8. Okay, let's look at, make sure those numbers are in your table. Okay, so hopefully, once you put all these numbers in the table, you can see a relationship between f prime of x and g prime of f of x. Do you see the relationship? 1 to 1, 2 to 1/2, 3 to 1/3, 4 to 1/4, 6 to 1/6, 8 to 1/8. That's right, it's the reciprocal. So what that means is that g prime of f of x equals 1 over the derivative of f of x. Now, it's important to remember here, guys, that this f of x is a y value of f, okay? This x is an x of f, all right? That's real important to make sure you know. Now, not only that, another way we can write that, so since f of x is a y of f, we can write g prime of y. Not really the best notation, but every once in a while you'll see somebody write it. And another way to write that is the derivative with respect, because remember g was just f inverse. So the derivative with respect to x of f inverse of x equals 1 over f prime of x. But again, notice there's two x's in here. But when you have an inverse, an x of the inverse is a y of the original function f. That's really important to be aware that these x's are not the same number, okay? Real important. Okay, so now we're going to use our chain rule and we're going to prove it. That we found by an observation. Now we're going to try to actually prove it. Now before I prove it, I want to make sure you remember something. So I'm going to ask you to recall that if f and g are inverses, then the composition f of g of x is the same as the composition g of f of x, and both of them equal x. Okay, so I'm going to take one of them, and I'm only going to do this for one now. Okay, and it works exactly the same if you use the reverse composition. We have f composition g of x equals x. We're going to take the derivative of both sides. So we're differentiating both sides, okay? Now the derivative of a composition, you take the derivative of the outside, keep the inside, times the derivative of the inside, equals the derivative of x is 1. Now if I solve for f prime of g of x, we get 1 over g prime of x. So this is the opposite of the one that we did in number 3. We did the reverse composition. Remember that this g of x is a y of g. So we could say that f prime of y is 1 over g prime of x, right? Or we could say that the derivative with respect to x of g inverse of x is 1 over g prime of x. And again, remember that's a y of g. That x value is a y of g. All right, so far so good? Let's try a problem. This is an old multiple choice question. It's from 1988. Okay, so here we have this multiple choice question from 1988. So they're telling us that if g of negative 2 is 5 and f prime of 5 is negative 1/5, they want us to find g prime of 2. What I forgot to type here is f and g are inverses. Okay, f and g are inverses. So if f and g are inverses, then g prime of negative 2 is going to be 1 over f prime of g of negative 2, right? Now what is g of negative 2? G of negative 2 is 5, so it's 1 over f prime of 5. So this is just the reciprocal of f prime of 5. And if we know that f prime of 5 is negative 1/5, then its reciprocal is negative 5. And that is the derivative of g at negative 2. That's it. Now here, with this example, I'm going to give you a more structured way to go about the problems, okay? So f of x is x cubed plus x, and we want to find the derivative with respect to x of the inverse of f of 2. Now remember, this 2 is a y value of f. So the first thing you want to do is find the matching x value. So if we take f of x is x cubed plus x. The y is 2. We need to find x. So let's see. I think the only number that when I cube it and add it to itself that gives me 2 is going to be 1, right? And you can check me on the calculator if you want to graph it or use C polyroots. The next thing we're going to do is we're going to find f prime of x, okay? So the derivative of x cubed is 3x squared plus the derivative of x is 1. Now we're going to take that x value we found and we're going to plug it into the derivative. So it's 3 times 1 squared plus 1, which is 4. The next step is to actually find the derivative of the inverse at 2. The way we do that is that we take the reciprocal of f prime of 1. So all it is 1 over 4. So, to repeat, we take the y value that they give us in an x position, because it's the inverse function. We find the matching x of f, we plug that into the derivative of f, and then we take the reciprocal. Let's try another one. Okay, last one. So here's f of x, and we want the derivative with respect to x of f inverse of 0. Now this 0 is a y of f. So the first thing we need to do is find the matching x value. So x to the 5th plus 2x cubed plus x plus 4 equals 0. You can use your C polyroots, you can use your graph, whatever you want to do. Find that root. And it should be -1. Okay? Next step, we find f prime of x. Derivative of x to the 5th is 5x to the 4th, plus the derivative of 2x cubed is 6x squared, plus the derivative of x is 1, plus the derivative of 4 is 0. Then we're going to take this new x value and we're going to plug it into the derivative. So 5 times -1 to the 4th plus 6 times -1 squared plus 1. That's going to give us 5 plus 6 plus 1. That's 12. Now we're ready to give the derivative of the inverse at 0. It's just the reciprocal of 12, 1/12. That's it, guys. All right? So there we are. We found how to find the derivatives of inverse functions without having to find the inverse itself, because sometimes it's really hard to switch the x and y's and solve for y. So it's easier to be able to find the inverse function. You find the matching x value, find the derivative at that x value, and then take the reciprocal. All right, guys, have a great night.